Lesson 5.5, Building Cubic and Quartic Functions. In this video, we will sketch a set of functions whose product builds a cubic with given characteristics. How do you mend a broken jack-o'-lantern? With a pumpkin patch. Sketch a set of functions whose product builds a cubic function with given characteristics. Explain your reasoning. So, number 1 says zeros at x equals -2, x equals 2, and x equals 3. So, x equals -2 could be written as a factor of x plus 2. X equals 2 could be written as a factor of x minus 2, and x equals 3 could be written as a factor of x minus 3. And we can graph each one of those on our number line, and that would get us three functions that create a cubic. So x plus 2 would have a y-intercept at 2 and across the x-axis at -2. Draw a line. Hopefully use a straight edge, get nice straight lines. Obviously mine did not go very straight. X equals -2 or x minus 2 has a y-intercept at -2 and an x-intercept at 2. And again, you can draw a line, hopefully be using a straight edge. And x minus 3 has a y-intercept at -3 and an x-intercept at 3. And again, you can draw, trying to use a straight edge, draw a straight line. This right here is 3 functions that create a cubic function if we take the product of them. What we could have done, okay, is done a quadratic, like a U shape, with a linear as well. And I'll show you an example of one of those after you've done your next example yourself. So with that, I would like you to try number 2. I'm going to explain one thing before I have you do it, and that is when it has a multiplicity of 2, that means that this is x equals 1 twice. Okay, which could be represented by 2 linear functions, okay, or it could be represented by a single function, a single quadratic function that comes down, touches, but doesn't cross, and then goes back up. So with that, go ahead and try this one on your own. Pause it, and then unpause to see how you did. All right, so let's go in and see how this works out. This is just one example of how this could work. Okay, I have it crosses at x equals -4, so that's one of the x-intercepts. And then because my graph comes down, touches at 1, and goes back up, that counts as a double 0. Okay, there are things as triple zeros. Okay, when your multiplicity is 2 or more, you can have multiple zeros at that same point. Okay, so this here would be one way of writing this. Again, you could do 2 linear functions right through x equals 1. Okay, that would work as well. The slopes of the functions doesn't matter, so you can make them steeper, you can make them more narrow. Okay, so when you are crossing the graph, the slope is not important unless it specifies something about the slope, which I don't believe any of the problems do. So with that, That's how you sketch a set of functions whose products builds a cubic function with the given characteristics. And your reasoning would be like mine there, a double zero, or showing that what kind of equation you're using. All right.